Actually, I can turn this on. Right now, what I'm doing here is making a digital pre-charge control system, and I found a way to cheat by using isolated power supplies to actually take voltage in and isolate an analog voltage signal out, because as you vary the voltage in and up and down, it varies on the output if it's a non-regulated isolated power supply, which I typically seem to use lately. Just for a little demonstration, I'll show where first I'll hit the reset button. That shuts my little Arduino relay off. Now I'm just going to measure pin A1. It's a little hard to do with one hand here. Try to get I'm not very good with chopsticks, and I'm trying to use one hand on probes. So basically, there I'm measuring pin A1. It's at 4.52. You can look, and the second LED is off on the relay. It's a simple little relay. I'm powering my 5-volt supply off the actual computer right now. I've got a bit of a little cluster of madness happening here. There we go. So basically, this is just to kind of bench test this thing. So basically, should be able to. I'm just trying to get this wire to stay so I can actually get this over, so we can actually see it here. There we go. So as I turn up the voltage on the second relay, you can actually see, and what I have it set right now is 90%, and I can adjust that anywhere I want. You see, it's not quite there yet. I'll try and go really slow, and then I'll measure it afterwards. It'll be easier that way. Gonna click pretty soon here. There it is. So basically, what I've done is I've set a system where it measures the voltage on pin 1 versus pin 2, and it says at X amount of percent, whatever I program into the Arduino, it'll turn on the relay, which is actually going to turn on my last contactor in the system. Now when I turn that back down, it stays on, doesn't matter. So any voltage fluctuations in the system, when you pin the throttle, whatever, turn both these down, it doesn't matter, it's going to stay on. That's all I want for now. Eventually I'll use the Arduino to display out an actual voltage based on a calibration of what it sees here, and this will be a tricky little way of isolating the output. What I have here is what I think I can do is use isolated or a voltage divider, because essentially when you turn these up to around where they run at somewhere, don't want to go too crazy because you don't want to feed more than 5 volts into the Arduino. It's a little sensitive as well. Once you, if you look at them, they're using next to no current. Like, I'd have to actually get something really accurate to measure the current, but it's essentially using next to no current through those isolated power supplies to send just a signal to the Arduino. All it's doing is sending a signal. I'm not looking to do anything like crazy, on power or anything, just using it as a signal. So right now they're at 3.72, 3.71. That side is using like, what is it, like maybe a tiny little bit of current. This side isn't even registering. So let's just turn this down. Yeah, the current gauge goes there at 0. I'll turn it up. A little tricky to do with one hand. So it'd be somewhere around there in typical running condition or something where I plan to run it. And I might use 0.01 amps or something like that. Enough that I can probably make that work with a voltage divider. I'll have to do some math. I think we can make this work. Either way, it's a cool little bit of code there for the Arduino.